All right, we're going to look at solving systems of equations using uh, three variables here. So systems with three variables, and everything we're going to talk about could work for more than three variables, four variables, five variables, six variables. Give you the general idea, but we're going to stick with three variables for right now. And so what I'm going to do is I'm going to start by showing how you might solve a system of equations by hand, and then we're going to move on to using a graphing calculator and matrices to solve this. If you already know how to do it by hand, feel free to skip ahead to using the calculator. We're going to use this 83 model here. If you have a Texas Instruments TI-84 or an 83 Plus, it's going to be basically the same thing. If you're using a different brand, what you'll want to first do is figure out how to do matrices in your calculator, and then kind of follow along with what we're doing, and you should be fine in those cases. All right, so let's start with an equation, a system of equations here. And so we got 2x minus 3y plus 7 z equals 0. And one of the most common mistakes people make is when they're writing down problems, especially these bigger problems, it's easy to shift from one line to another. So just double check your work. Make sure you get the problems down written right. Because no matter how good you are, if you got the wrong equations, you're not going to get the right answer. So let's see. Let me double check here. It looks okay. All right. Okay. So what we're going to do is we're going to use elimination to do this by hand, and which means we're going to add these equations together and get rid of certain letters, and then work our way down to a single equation with one letter. I'm going to label these. This is equation A, B, and C. Just kind of keep things organized. And so I need to put two of these together. Now, there's different ways you can do it. I know like what we're using in our classes, they always get rid of the X's first, and then they get rid of the Y's, and then they get rid of the Z's. You don't necessarily have to do that, but it would, if you're doing it by hand and you're trying to check your answers in the back of the book, especially in some of the dependent cases, you would want to do it that way. So I guess I'll just stick with that method. So we'll get rid of the X's first. So what I'm going to do is I'm going to combine A with negative 2B, and that'll make a 2x and a negative 2x, and that'll get rid of our x's one time. So we're going to keep A the same, minus 3 plus 7z equals 0. I'm going to multiply everybody by in B by negative 2, so negative 2x, negative 8y, positive 8z equals positive 4. Now, the second most common mistake is not multiplying everybody in an equation by whatever number you decide to use. Like leaving that negative 2 as a negative 2 instead of making it a positive 4. It's a very common mistake. All right, so let's add these together. Our x's are going to cancel out. That's what we wanted to happen. Negative 11y plus 15z equals 4. And I'm going to call this little a. So now we have a new equation with two variables, y and z. So we're going to go back, and this time we're going to get rid of x. And we have to use a different pair of equations than we've already done. So we did a and b, so we either need to do a and c or b and c. And get rid of x again, get whatever variable we got rid of the first time. So I'm going to do b and c, and I'm going to multiply this time b by negative 3, and I'm going to leave c as c. So that's going to be negative 3x, negative 12y, positive 12z equals positive 6, and then c we're going to leave the same. 5c equals 1. We're going to add again. We set this up so the x's would cancel out. We get negative 10y, positive 17z equals 7, and this is going to be little b. And now what I want to do is put little a together with little b and get rid of a letter. So as they're written right now, they're not going to get rid of anything. I'm going to have to change them. And it looks like I'm probably want to change both of them. It's not a great choice which one to match up. And like I said, the book likes to get rid of the y's next. So given the choices here, that looks like the best choice anyway. So let's multiply negative 10 times little a. So that'll make it a positive 110. And let's do 11 times little b, and that'll make it a negative 110. So multiplying everybody in the first in little a by -10, that's going to give us 110y negative 150z equals -40. Multiply everyone by 11 on B is negative 110y. Let's see, 11 times 17. That's going to be a positive 187z, and then equals 77. All right. So combining those equations, looks like we're going to get 37z equals 37. All right, solving that equation, divide both sides by 37, z equals 1. And we are a third of the way done. So we're looking for an order triple answer here, right? We're looking for x, y, and z. We got z equals 1. What we need to do now is go to an equation that has z and one other variable and figure out that value. So we can go to little a or little b, probably be good choices. I'll just use little b here. So let's go ahead and put in 1 in for z. So 17 times 1 is 17 equals 7. Solve that for y. So subtract 17. Negative 10y equals negative 10. Divided by negative 10. And it looks like y equals 1. Okay. And now we need to figure out x. And so we'll go back to one of the original equations, probably b here, and plug in those values. So let's see, if I use b, I'm kind of cramped on space here, but I don't want to go to another slide. Let's just change colors. So I'm gonna use this equation b. So x, if y is 1, that's positive 4. If z is 1, that's negative 4 equals 2. Well, those 4s are going to cancel out. Looks like x equals 2. So there we go. So that's kind of how you do that by hand. As you can see, I was running out of space. It takes up a lot of room to do a problem like this. And so what we want to do is find a more efficient way to do this. And that's where we're going to use matrices. Since we already talked about matrices, we can use matrices to solve a system of equations. So let's take a problem and find its solution. And let's go, yeah, I'll just pick one. Let's see, 3x plus y minus 2z equals 2. Second equation, x plus 2y plus 3z equals 13. And third equation, 2x minus 2y plus 5z equals 6. Now, we did solve system of equations briefly with matrices. We did inverse matrices to solve it. There's a problem with that. Inverse matrices don't work when you have a dependent system or an inconsistent system. And what's worse is you don't know which one it is. So we're going to do a different technique than the one we did with inverse matrices. What we're going to do is we're going to translate this system, and this is where the amount of work you have to show on your homework is going to come in. All right, so we're going to translate this system into an augmented matrix. We're going to combine the coefficients. So remember, those are the numbers in front of our variables. So we're going to the coefficient matrix, and we're going to join that with the constant matrix. Give me a second here. All right, get back to here. So, oops. Right. So we're going to make that augmented matrix. And then we're going to put this matrix in RREF, reduced row echelon form. And I know you're groaning, no, but we're going to let the calculator do it for us. Let the calculator. So first we need to put this in our calculator. So for most of your calculators, what you're going to find is an x to the -1 And right above it, you should, mine says finance, but yours will probably say matrix. I have an actual matrix button, but I'll keep referring to hitting second x to the -1. So if you're using one of those models, you'll know what we're talking about. All right, so you're going to hit second x to the -1, and you're going to get your matrix menus, and you're going to see this. There's 3 options along the top. The names of the matrices, matrix math, and then edit. And what we're going to need to do is use the edit function to put this matrix in there. And it doesn't matter. You can pick different matrices. If you already have matrices in here, you can just copy over them. It's fine. I'm just going to use A. So I'll select A. And the first thing it wants is the order of our matrix, the size of it. And this is a 3 by 4. We're going to put the whole thing in there at one time. So this is a 3 by rows by 4 columns. And then I'm going to type the numbers in. And you can use your arrow buttons here to kind of move around if you want, but it's actually faster if you just type the number in and then just hit enter, and it'll take you to the next location. So 1, -2, 2. And remember that line there that I put is merely decorative. It doesn't do anything mathematically. So don't try to kind of make that get into your calculator. We're just going to ignore it for now, right now. So type those numbers in there. -2, 5, and 6. All right. Once you have all the numbers typed in, and again, if you mistype something, you can always use your arrow keys to kind of come around and fix it. Also, be sure you're hitting the negative button and not the minus button. The calculator will probably give you an error message. If I try to say -2, it'll probably say syntax. Yeah, syntax error. And so you got to be careful you're using the -2, right? So once we get all those in there, we're going to hit second and quit. We're going to go back to our normal screen. And then we're going to do our math. So we wanted to do reduce row echelon form. So we're going to do second x to the -1. Again, go into the matrix options. And this time we're going to go to math. And you can go down, or you could go up. Up's faster. And what you'll find is REF, that's row echelon form. We don't want that. Or there's our REF, reduced row echelon form. That's the one we want. The reason why you don't want row echelon form, one, it's not going to take you all the way to the answer. And the second reason is row echelon form is not unique. You can have different, for the same problem, you can have different REFs, different row echelon forms, because of the whole flip-flopping rows and stuff. But there is only one reduced row echelon form for a matrix. So that's the one we want. So we're going to say reduce row echelon form, and you'll notice it starts it with a parenthesis here because it's like who are we going to do it. So we're going to hit second and go back into the matrix menu, second x to the -1. And under names, you're going to go and select which one you want. So again, I put mine under A. So I'm just going to hit enter. I'm going to close the parenthesis. Now, it's possible you might get fractions. In that case, you might want to go ahead and just hit math, your normal math button, and then choose fractions. And it'll convert any value you get that isn't an integer into a fraction. And so let's hit that answer. All right. And now we're going to write down this answer on our paper. So again, we're going to show some work. You're going to write down what did you put in your calculator? And then I'm going to write down what did my calculator tell me as an answer? So this is what my calculator told me as an answer. All right, and I'm just going to put that line back in there. Again, you don't need the line, but I find it easier a little bit to kind of see what's going on if you have that line in there. So this is what it told me as an answer. So I need to write down the first matrix. I need to write this answer matrix down, and then I need to interpret what this answer is. Now, I would strongly recommend you go ahead and translate this back into equations. So if you remember, if you kind of look back at the original problem, 3 was the coefficient of x, 1 was the coefficient of y, -2 was the coefficient of z, and then equals 2, that was the constant that it was equal to. So if I kind of just do that here, what I would see is the first line, I have 1x, no y's, no z's, equal 1. And then if I translate the second line, I have no x's, I have a y, no z's, equals 3. And on the third line, I have no x's, no y's, 1z equals 2. What that means is there's my solution. X is 1, Y is 3, Z is 2. Now you can't leave it like this. You need to go ahead and write that as an ordered triple, X, Y, Z. So that's how you do that. Okay, so let's do another one. And let me say, you will want to practice this a lot. There's usually one of these problems on the final. You can just do it on your calculator, get the answer, but you'll need to practice it because when you get to the final and if you don't remember how to do it, you're going to be pretty sad because I won't be able to tell you during the final how to do it. All right, so let's try another one of these. Let's try, let's do kind of an unusual problem. So let's do 2y plus z equals 7, 2x minus z equals 3, and x minus y equals 3. Okay, so let's say I want to solve this system of equations. So the first thing, again, I need to show on my paper is translating this into a matrix. Now you'll notice I'm missing an x in the first equation, a y in the second equation, a z in the third equation. I'm just going to put their coefficients as 0. So 0, 2, 1, and then I have that constant value of 7. The second row is the second equation, so 2x, 0y's, negative 1z, 3 is a constant. Coefficient of 1, coefficient of negative 1, 0, and 3. And be careful. Make sure you get your signs. Don't leave, like this negative y on this third equation. Don't write that as a 1. It's a negative 1 coefficient. All right, again, I'm just going to put that line in there. You don't have to. So that's the first thing you need to show on your homework. Then I'm going to do RREF. Okay, and the calculator is going to tell me. So let's go through that again. I'm going to hit second matrix for you. I'm going to go over to edit. I'm going to select one. So let's say I don't want to, for some reason, I want to keep matrix A. Maybe you want to do like A times B or something. I don't know. But I want to put this in. I want to keep matrix A for some reason. So I can move down. Let's store this as C. Again, you don't have to do that. You don't have to use different matrices if you don't want to. So this is a 3 by 4. And again, I'm just going to go through and plug my numbers in. 0, oops, getting ahead of myself. 0, 2, 1, 7. And if you just hit enter every time, it'll just move you along row by row. But if you find you type something in wrong, go back and correct it with your arrow, use the arrow keys to kind of move around the matrix to go back and correct any mistake you made. Once you get all those numbers in there, then we're going to hit second and quit. Second and quit. That's going to take us back to the normal screen. Okay, I'm going to like to clear it out, see what's going on. Second matrix. And like I said, you can go over to math, and it's faster to go up than down. So if you push up, you can come from the bottom, move up to that RREF, reduce row echelon form. And it's going to say of who, and you're going to hit second in matrix, and under names, remember I stored mine under C. That's where you're going to pick it. I'm going to close it. Maybe I'll get fractions, maybe I won't. Just to be safe, I'm going to go ahead and hit my normal math button, change to a fraction. So if there's any fractions in there, it's going to give it to me. And there you go. All right, so no fractions. So I'm going to write down on my homework, what did I get here as an answer? Okay. And now, like I said, you don't have to write it, but I would recommend you go ahead and translate that into equations. X equals 4, Y equals 1, Z equals 5, and then write your order triples answer. 4, 1, 5. All right. And so that's how most problems are going to go. And you can just go straight to the answer. Now, of course, that's most problems, not all problems. So let's look at some problems that are a little unusual here and see if we can see how to handle them or understand what we're looking at. So let's look at a system of equations here that might give us a kind of unusual answer. So 2x plus 4y minus 2z equals 3, x plus 3y plus 4z equals 1, x plus 2y minus z equals 4. Okay, so I'm going to put that in. Again, I'm going to write down the matrix. I'm going to put that in as, so 2, 1, 1, 4, 3, 2, -2, 4, -1, and then my constant values, 3, 1, and 4. Okay, so let's see what this looks like. So second matrix, go over to edit. That's where you put things in. You're editing them. I'm going to put mine under A again. 3 by 4. This is 3 by 4 matrix. 2, 4. Just type those numbers in just like we did before. All right. Once you have all the numbers in there, we're going to hit second and quit. Go back to our normal screen. And now we're going to tell the calculator to put this in reduced row echelon form. So second matrix, go over to your matrix math. So that's a determinant of a matrix, so you know you're in the right spot. I'm going to go up, reduce row echelon form, second matrix under names. Again, I put this one under A. I'm going to select that, close it. And again, I might get fractions, so I'm just going to head math, change to a fraction just in case. And we get this matrix. Now you might be tempted to say, oh, the answer is 0, 0, 1. This is why I want you to write out, whoops, didn't mean to do that. This is why I want you to write out what it gives you. So you're not trying to go too fast and making mistakes. On the test, it's up to you how much you want to write out, but on the homework, I want to make sure you're writing out everything the calculator told you, and then we're going to go step by step here. All right, so -11, 5, 0, 0, 0, 1. Okay, so let's translate this into equations and then see what's going on here. So remember, the first number is the coefficient of x, second number is the coefficient of y, third number is the coefficient of z, and then on the fourth number is what it's equal to. So this first line is going to translate as 1x minus 11z equals 0. The second equation is going to so notice that is not an answer. It's not x equals a number. There's z's involved. The second equation is going to translate as 1y plus 5z's equals 0. And then the third line, 0x's, 0y's, 0z's equal 1. Well, 0 can't equal 1. 0 is 0 and 1's 1. This system is inconsistent. The system is inconsistent, or in other words, no solution. There's no solution to this system of equations. That's what that means. So if you see this third line is 0, 0, 0, 1, that's going to be an inconsistent system. You know that. Okay? So that's one type of special situation that can happen. All right, so let's look at another special case situation we could run into. So x plus 2y minus 7, keep doing that. 7z equals -4, and then 2x plus y plus z equals 13. 3x plus 9y minus 36z equals -33. Okay, so first thing we need to show on our homework is the matrix we're going to type into our calculator. And let me say, you don't have to do these problems using a matrix. You could do each of these problems by hand. It's just a little bit harder than typing it in the calculator. So I would recommend you use a calculator, but that's up to you. All right, so second matrix, edit. I'm just gonna, I like to reuse the same one over and over unless there's a reason for me to have more than one matrix. It just makes it easier to keep track of what's going on here. But, feel free to use all your different matrix slots if that's what you want to do. -4, 2, 13. 6 and -33. Okay. Again, once you get all that typed in there, and again, watch your signs. Don't leave off a negative. We're gonna hit second and quit. We're gonna do second matrix. Again, second x to the -1 will take you to your matrix menu. Go over to math, reduce row echelon form, second matrix, second x to the -1. I'm gonna choose my matrix A. That's where I put it in. Math, change to a fraction, might get fractions. And there we go. We haven't got fractions yet, but you could get fractions. So let me write down what the calculator told us. Again, you need to do this on the homework. What did I put in my calculator? What did my calculator tell me as an answer? And then I'm going to need to interpret that answer. Okay. All right, so remember that was a little separator. So first column is your x's, second column is your y's, z's is the third column, and then what it's equal to. So I have an x plus 3z equals 10. I have a y minus 5z equals -7. Now in this bottom row, I have 0 x's, 0 y's, 0 z's equals, and 0 on the other side. Well, that is a true statement. 0 equals 0. This system is dependent. This is actually, let me not write it there because we're going to need some space here. This system, because of this 0 equals 0 as my third equation for my 3-variable system, this system is dependent. Now, if you have more than the number of equations that you do, like if I had 4 equations with 3 variables, I would automatically, even if I had an answer, the bottom row would come out to be 0 equals 0. That doesn't mean it's dependent. That just means you had an extra row that you didn't need. In this case, I had exactly 3 equations with 3 letters, so I should get a single answer, but I got this bottom row of 0 equals 0. In this case, it does mean it's dependent. Now, when it's dependent, we also have to write out the format of that. And what you're going to find is oftentimes the dependent version, z is going to be your independent variable, what everybody is based on. And the reason why is it is easier to translate these two equations that we have up here into x equals 10 minus 3z and y equals 5z minus 7. See how I can say, oh, x has a z in it, 10 minus 3z, and y has a z in it, 5z minus 7. And that's the format. Now, again, a lot of times they'll just change these to a different letter like A or C, and it'll look something like that. You don't need to do that. You can just leave it as dependent upon the variable z, but you will notice sometimes they do that. Okay? So that's what happens when you get one of those dependent systems. And let me just make up a problem. I have no idea what this answer is going to look like, but let's say we have like 3x minus 2y plus 5z equals 4, and 5x plus 7y minus 3z equals 11. Okay, so I have no idea what this answer. I've never done this problem. We're going to do this system of equations. Now, what we should immediately notice is I'm not going to get a single answer for this. I'm not going to get an order triple, and I can't because I only have 2 equations with 3 variables. But if this is dependent, in other words, it's not inconsistent at this stage, then it's going to have some format to those answers, and I need to find that. So I'm going to do, again, second x to the -1 matrix, go over to names, edit. This time, this is 2 rows by 4 columns. So 3, I'm going to put these in. Again, I just made this up. It's probably going to come out ugly if it comes out at all. I just wanted to show what happens if we don't have enough equations. So once I get that typed in, I'm going to hit second, quit, second matrix. I hope this is getting kind of like repetitive. You're like, yeah, we already know that. Great, great, that's good. RREF, second matrix, under names, and again, I put mine under A. That's where my 2x4 is. And I'm hoping I'll get fractions here. So I'm going to go ahead and say math, get fractions. Oh, good, we got fractions. Awesome. I was getting a little worried we would never see a problem that has fractions. Okay, so let me translate this. So this is RREF 1001 29 over 31 negative 34 over 31. And you'll notice like mine, I need to see a little bit. If you have a newer model, it probably shows it all, but I need to actually push to the right to see the rest of this matrix. So let me do that and then go ahead and write the rest of this. 50 over 31 and 13 over 31. So there is my matrix. So if that bottom row had been 0, 0, 0, 1, I would have said, oh, it's inconsistent. This is dependent. I know this is dependent. I'm going to go ahead and translate this back. 29 over 31z equals 50 over 31. Y minus 34 over 31z equals 13 over 31. And like I said, there's only 2 equations. This has to be dependent. If it's not inconsistent, it has to be dependent because you don't have enough equations to get a single answer. So let me go ahead and translate these two, solve it for x. So 50 over 31 minus 29 over 31z, y equals 34 over 31z plus 13 over 31. And you notice all these have they're over 31 over that same denominator, and that's probably the determinant for this matrix. Well, I guess not in this one because it's not a square, but it's basically functioning that way. All right. Okay, so our answer is our x's, which look like this, comma, our y's, our 34 over 31z plus 13 over 31, comma, z. Again, you could translate all those z's to a different letter, but you don't need to. So there is our system. And again, you need to do both. You know, not only say it's dependent, but you also have to say the format of those answers for it. All right. And then the last few problems are actually going to ask you to find an equation, and they're going to give you some points to find the equation of whatever they're talking about. So let's say they ask us to find the equation of the circle that passes through, and they're going to give us some points here. So let's say they gave us, what they give us? Okay, they gave us -3, 3. They gave us, well, actually, let me not do that one. Let me find a different circle equation. So give me a second. Okay. Yeah. Let me change that point here. Still going to be finding the equation of a circle, but let's use some different points. So let's do 4, 2, comma, 0, 1. Still pretty easy. All right. 3, negative 1. Okay. Now, we haven't talked about circles yet, so we don't really know what the equation of a circle looks like, so they're going to have to give that to us as well. So they're going to tell us something like the equation looks like x squared plus y squared plus cx plus dy plus e equals 0. And we're going to need to find out what this c, d, and e values are. Now notice, we don't know 3 values, and they gave us 3 points. Well, that was deliberate. So what we're going to do is we're going to say, take the first point, and the first point says, when x is 4, y is 2. So we're going to go to our equation that they gave us, and we're going to turn all the x's to 4s, and at the same time, we're going to turn all the y's to 2. So this is going to be c times 4 plus d times 2 plus e equals 0. And then we're going to come to the second one. We'll clean that up in a second. When x is 0, y is 1. So we're going to go and we're going to make all our x's 0, all our y's 1, c times 0, d times 1 plus e equals 0. And last, when x is 3, y is negative 1. So we're going to make all our x's 3, all our y's negative 1. So c times x plus d times y plus e equals 0. And then we're going to make this look nicer. So if you notice on the other problems we've done up to this point, you had your letters on one side and the constant values on the other. So what we want to do is when we clean this up, we want to make it look like that. So on the left-hand side, we want our letters and then just the numbers on the other side. So I'm going to do some moving around while we clean this up, and hopefully nobody gets too lost. Okay, so I'm going to do 4c, okay, plus 2d plus e equals. And then I'm going to move this stuff to the other side. So I'm going to figure out what this stuff is. So 4 squared is 16, 2 squared is 4, 16 plus 4 is 20. So I'm going to move that to the other side. But when I move it there, it has to change sides, all right? I have to subtract 20 to the other side. So that's what that first equation is going to look like. My second equation, 0c, 1d plus e equals, again, I'm going to figure out what this stuff is here. 0 squared is 0, 1 squared is 1. Then I'm going to move it to the other side. So it's going to be a negative 1 on the other side. And then on this third one, 3c plus, oh, let's not say plus. Let's say minus d, right? Negative 1 times d, so minus d plus e equals, and I'm going to figure this out. 3 squared is 9, negative 1 squared is 1, 9 plus 1 is 10. Move 10 to the other side of the equation, you get negative 10. All right, so this is my system of equations that I want to solve. So I'm going to change that to a matrix. 4, 0, 3 are my x's. 2, 1, negative 1 are my y's. Or why am I saying x's? C's. The c's, my d's. 1e, 1e, and 1e. So all my e's have a coefficient of 1. And then that's going to equal negative 20, negative 1, negative 10. Okay? We're going to put that in our calculator just like we have been. So clear that out. Second, x to negative 1 to get the matrix. Put that in there. This is a 3 by 4. We're just going to type those numbers in and have it put it in reduced row echelon form for us. And again, if you need to, you can use the arrow keys to kind of move around. But if you just type and hit enter every time, it'll just move you to the next location. All right. Make sure you hit enter on that last one too. And once you get that all put in there, again, second, quit, always go back to your normal screen, and then second, x to the -1, second x to the -1 to get the matrix. Go to math, up to reduce row echelon form, second, x to the -1, second matrix. Under names, make your selection, close it. Again, maybe you might get fractions, maybe you're not. Math. By the way, if you don't do this here, let me show you what happens if you don't do it. Okay, so let's say I don't do that whole hit my normal math button and choose to make fractions. I hit enter and I get something nasty like this. I knew this was going to have fraction. And oh man, that's gross. I can't write that down. I need fractions for those. Well, you can just hit math, change to fraction. You'll see. You'll say, oh, I'm going to take your answer and turn it into fractions. So that's okay if you don't think about doing it. So there we go. All right, so we did get answers. They're not pretty answers, but we did get answers here. So we got 1, 0, 0. Again, you need to show this work when you're doing your homework. You know, what did you get as an answer from the calculator? 10, 11, I'm kind of squeezing it there. Okay, so that means C has a value of -47/11. D has a value of -21/11, and E has a value of 10/11. Now, normally I would write that as an ordered triple, right? But I'm not going to do that here. And the reason why is because we were trying to find the equation of the circle. And this is what the equation looks like. And the whole goal was to figure out what the C value is, what the D value was, and what the E value was. So on this particular problem, because I was looking for that equation, I'm going to write out x squared plus y squared, was it -47/11 x, -21/11 y, plus 10/11, and this says equal to 0. That's what they told us. And that is the answer. So if you're not told you're doing something like that, you shouldn't do it. You should write an ordered triple. But since in this case we're looking for this equation, this is how we're going to do it. All right, hopefully that'll help you take care of that section of the homework. Thank you.